Activity 5, Completing the Square. This activity is part of Unit 4, Applications of Quadratic Relations. Perfect squares. A perfect square is a number that is the square of another number. In other words, it is a number whose square root is a whole number. For example, 3 squared is equal to 9. 9 is considered a perfect square. Examples of other perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. All of these numbers have square roots that are a whole number. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4, and so on. By definition, a perfect square is formed by squaring another value. Therefore, x squared would also be a form of a perfect square. Here are some other examples. 1 minus x squared is a perfect square. So is a plus 5 squared, or a plus b squared, or 2x plus 5y squared. Perfect squares. Can you see a pattern to move directly from the first line to the last line for each of the following examples? In other words, can you find a way to go from the factored to the expanded form more quickly? Here's the factored form. 1 minus x squared. Here it is expanded. 1 minus x plus x squared. We've regrouped the like terms, and our final expanded form is 1 minus 2x plus x squared. How about this one? A plus 5 squared. That's the same as saying a plus 5 times a plus 5, which is equal to a squared plus 5a plus 5a plus 25, which is equal to a squared plus 10a plus 25. Do you see a pattern here yet? Let's try another. Y minus 3 squared. It's the same as saying y minus 3 times y minus 3. Y squared minus 3y times 9. And finally, y squared minus 6y plus 9. A plus b squared. That's the same as saying a plus b times a plus b. This expands to a squared plus ab plus ba plus b squared, which is the same as saying a squared plus 2ab plus b squared. Let's have a look for the pattern. Notice the a. It turns into a squared. The 5 becomes a 25. And what about the 10a? We'll do 2 times x, or in this case it's a, times 5. Let's look at another one. The y turns into y squared. The second term, negative 3, becomes positive 9, which is negative 3 squared. And finally, we take the middle term, which is 2 times y times negative 3. So we're multiplying y and negative 3 together and multiplying it by 2. The final answer is a trinomial. The first term in the final answer is formed by squaring the first term in the binomial. So our first term in this one is y. It gives us our first term, y squared. The last term in the final answer is formed by squaring the last term in the binomial. So the last term here is negative 3. It becomes negative 9. We've squared negative 3. The middle term is double the product of the two terms of the binomial. So we take y times negative 3, which is negative 3y, times 2, which is negative 6y. Trinomials that are perfect squares will always have the third term positive. This is because it is formed by squaring a number. The sign of the second term is the same as the sign between the terms in the binomial being squared. So, if it's a negative here, it'll be a negative here. If it's a positive here, it'll be a positive here. Is the given trinomial a perfect square trinomial? If so, write each as a perfect square. Are two of the terms in the trinomial perfect squares? Is the third term, usually in the middle, double product of the square roots of other two terms? So here's an example. Is this trinomial a perfect square trinomial? To find out, we can write this: x squared minus 8x plus 4 squared. This is equal to x minus 4 squared. How about this one? X squared plus 2 times 1 times x plus 1 squared. So this is equal to x plus 1 squared. The next one, a squared minus 16a plus 64. Is this a trinomial that comes from perfect squares? A is a perfect square, 64 is a perfect square, and the middle term, negative 16a, is 2 times 8a. So it works. A minus 8 squared. How about this one? Is 2 a perfect square? This is not a perfect square. So the given trinomial is not a perfect square trinomial. We're going to match the missing middle terms with the perfect square trinomials. Then we'll factor. So, a squared minus what plus 16 will make this a perfect square trinomial. How about this one? What will make this a perfect square trinomial? Here we have our options.